Good day. So today I'm going to show you how to deal with calculations when payment end early, right? Maybe the guy is supposed to be paying for 5 years and the guy decides to stop somewhere even before the 5 years is completed. So what do we do in this situation? Before we deal with it, I want you to understand what is the difference between the grade 11 formula and the grade 12 formula. So in grade 11, we're using compound or simple interest, right? So this is a situation where we put money once in the bank and it will just grow, right? So if the person is investing something, maybe the person will pay once, right, and leaves it to grow, right? So the person pays once, leaves it to grow. But in the metric formula, the person is paying for a consistent period of time, maybe every week, maybe every month, maybe every 6 months, or maybe every year, right? So the person is paying for a consistent period, right? That is now when we're dealing with annuity situation, the grade 12 formula. So the difference between the grade 12 and the 11 formula, the grade 11 formula, the person puts money once in the bank and leaves it to grow. In the grade 12 formula, the person is putting money consistently. Yes, the money is growing when we leave it at the bank, but now this guy keeps adding. So meaning that the money grows even quicker. So let me just do a small example before we do this one, right? So let's just say the person leaves his leaves his money in the account for 2 years, right? So the person leaves his money in the account for 2 years. Then all of a sudden the person stops paying monthly, right? The person stops at 1 year 6 months. So the person puts his money for a total of 2 years in the bank, right? But the person stops paying on 1 year 6 months. So basically the payment ended 6 months early, right? So these payments that end early. So the person was paying every month up until 1 year 6 months, and then leaves his money for 6 months leaves his money to grow for 6 months. So the time the person is paying with a consistent with a consistent period, so you'll calculate that part using the grade 12 formula because it's paying consistently up until 1 year 6 months. So what you'll do is you'll calculate using the grade 12 formula for 1 year 6 months. So use the grade 12 formula. So since the person was paying for 1 year 6 months, maybe the person is paying every month, then it means we will calculate that part using okay, so let me just substitute this one. I'm not really solving it. What we'll solve is this one. So basically we're first dealing with the 1 year 6 months. So let's just say the person decides to pay, just an example, the person is paying 500 for 2 years, right? The person stops paying at 1 year 6 months. So what we're gonna do is we're gonna calculate 1 year 6 months. So 1 year 6 months, it's obviously 18 months. So it means it's gonna be 1 plus, and I'm not gonna substitute the percentage because I didn't tell you what percentage is it. So I'm not gonna give that percentage yet. I just wanna show you the substituting part. That is all. Then we'll come there where we're given the percentage and stuff. So what we're gonna do is this is gonna be okay, my mind was not here. So this is gonna be it's 18 months, right? So it's 18 minus 1. So basically we're dealing with the 18 months. When we get the answer of this part, then this part is what we have after the guy has been paying, right? But the money is left in the bank, right? He stops paying early, yes, and then the money is left at the bank. So what do we do in this situation? So what happens to the money when it's left by the bank? Does it just stay? No, it doesn't just stay. It grows, right? So it grows using compound interest for 6 months, right? Remember that guy has been paying for 18 months and then decides to stop paying for 18 months, right? So he decides to stop paying for 18 months. So we have to use the future value for that period, right? So the future value was used for the part where the person has been paying consistently, right? And then now that the person ended early, it has no money is dropped in the bank. Money is now there in the bank, right? But he's not doing any other thing. He's not adding any cash and stuff. It's just there in the bank. So it means it will grow for 6 months using the grade 11 formula, right? So it means when you're done with this thing, this becomes the principal amount. So the accumulated amount is equal to the principal amount. Then we have 1 plus I all to the power of n. So the answer that you get here is now part of this, right? It will grow using compound interest. And then we know the percentage that we have here is the same as the percentage that is there. I just didn't deal with it. I'll deal with it on this question that is written in black. And then for n, what should we put in place of n? The person is paying monthly, right? And then leaves his account to grow, right, for further 6 months, because he stopped paying when we used the future value, but then he continued, he left the money at the bank, and then the money continues growing, right? So it will grow using compound interest, and in place of n, it will be 6, right? Because it grew for how many months? 6 months, right? So it grew for 6 months, so the payment is gonna grow using compound interest. So I want you to just first of all understand the fact that there is the situation where the guy is paying consistently. We'll calculate that using the future value, and then the money, the amount of time that is left where the money is not being put, it still grows, right? The fact that it's in a bank, it will still grow, right? The fact that it's on an investment account, it will still grow, whether you leave it like that or you keep adding. So since it's in the bank and the guy didn't take the money from the bank, the guy left it, it means this is the principal amount. It will grow for 6 months. Okay, so let's deal with the actual question. All right, let's read this scenario. So it says Thabang pays a monthly amount of 1.5, right, at an interest rate of 9% per annum, compounded monthly, right? So we know this is an annuity situation because they told us the interest is 9%. The interest is monthly, right? And also the guy is paying monthly. This is always like a repetition. If they say the guy pays quarterly, also the interest will be quarterly. So there is the period for the interest and there is the period of the guy paying. I will explain it in detail in another video. So it's 9% per annum component monthly for 30 years. So this guy is going to pay this for 30 years, right? That's what they're telling us. They're telling us that this guy is going to use, is paying every month, all right, 1.5 every month. And then it's going to continue it's going to continue until 30 years, right? So we know how long it's going to pay. And then they said something else. They said at the end of the 30 years, he stops paying, right? He stops paying his monthly payments. So he has been paying for 30 years. Then they said after the 30th year, he stops paying, right? He stops his monthly payments. But they said something else. He leaves his money at the bank for a further 2 years, right? So basically, the guy has been paying for 30 years, right? And then he stops his month on the 30th year and then leaves it for a further 2 years. So it means the first part up until the 30th year will be the grade 12 formula, right? Because it's paying monthly. It's a consistent period. So let's get the future value. It means it's going to be f is equals to x into, this is going to be 1 plus I to the power of n minus 1 over I, right? So now let's deal with the substitutions. The guy is paying 1.5. So the guy is paying 1.5. And then what other thing do we have? There's going to be 1 plus. The percentage was 9%. So it means it's going to be 0.09 divided by, the guy is paying monthly. So since the guy is paying monthly, we have to divide by 12. And then from there, if you look at this stuff, n will be the number of years times the number of payments, right? So it's going to be, what's the number of years? We know it's 30 years. And then 30 times 12. I think it's going to be 360. So that's what it's going to be. So this is all divided by I again, which is 0.09 over 12. Alright, so I substituted 30 because the guy has been paying up until the 30th year. Okay, so using the method, this is the answer we're gonna get. So now we continue. So the answer is this, right? So when we finish the 30th year, this is gonna be the answer, and then this is gonna be left in the account for a further 2 years. So let's calculate that. So this was the answer that we got, right? So the money is left for a further 2 years. So it means we're gonna use the compound interest formula, right? So this is gonna be this stuff. So A is what we're looking for. So what will the guy have in total? Is what's gonna grow after this. So your principal amount now becomes this stuff, right? So it becomes 2746115, and this was a rounded off answer, right? We're dealing with cash, so we had to round off to 2 decimal places. And then this is gonna be brackets. So remember this was P, and then this is gonna be 1 plus 0.09 divided by 12. So the money is gonna grow for a further 2 years, right? So we're gonna say 2 years, and that 2 is gonna be multiplied by 12 because it was monthly. So then this is what we have. So the money was left and to grow for a further 2 years, right? So this is the amount that we have when it grows for 2 years. Let's find out what exactly it is. Alright, so this is the final amount. So remember, where the person is paying monthly, we just use the Great 12 formula, and then when the person leaves money to grow, it will grow via compound interest. Alright, so thanks for watching this video. If you like the video, just give me a thumbs up, and if you want to see more things like this, subscribe to my channel.